Mr. Drzezinski. I'm going to start the rock activities number 1 through 7 for those of you that can't be in the classroom. Rocks activity step number 1 says define density. You can do that by looking that up on the internet for definition for density. Step number 2, write an equation for density. Density is going to require you to know the mass and the volume. We'll be calculating the mass today on the digital scale, and we can calculate the volumes of the rocks using the graduated cylinder. Density is mass divided by volume. What are the units for density on step number 3? Mass is grams, volumes is cubic centimeters, so the units for density are grams per cubic centimeters. That would be G/cm to the 3rd power. When you go about filling in the appearances for the rocks that we're going to do today, there's a word bank there. Rocks are either layered or not layered, dull or shiny, crystal or not crystallized, porous or not porous, light color and dark color. The 4 rocks that we'll be looking at today: granite, basalt, obsidian, and pumice. I have a little cup with a sample of granite, a little cup with a sample of basalt, a little cup with some obsidian, and a little cup with some pumice. It's falling apart. Okay? If I continue, it says on step number 4, find the density, classify and describe the appearance of each rock sample. Rock number 4 is the granite. Classification is igneous. Igneous rocks come out of the ground as molten magma, turned to lava, cooled to make igneous rocks. If I take a look at the appearance of the granite, this is a chunk of granite from a countertop. I can see that they polished it there. Okay, and then it has lots of colors in there. I would say that this is lighter colored rather than darker colored. It has large greens in it. It's a little bit crystallized. If you take a look at it, the light will bounce off it in such a way as it looks like a crystal. I would say it's shinier rather than dull. Okay, that's the appearance. Next, I'd like to calculate the mass. Let me bend the camera down for you. I've set the granite on the scale, and it's reading 82.8. 82.8 grams. You can write that down. Next, I'm going to calculate the volume, and you can either do that in the graduated cylinder, but this thing is not going to fit in the graduated cylinder. So I have 100 milliliters of water in this small beaker, and let's see if I can calculate the volume in there. This went from 100 milliliters up to somewhere about 140 milliliters. That's going to give me a difference of 40 milliliters. And for the volume, I'm going to put 40 cubic centimeters. 40 cm to the 3rd for the volume of the granite. Now to finish the density, you're going to want to use your calculator, and you'll do grams divided by cubic centimeters. That's 82.8 divided by 40. Remember that the density of water is 1. So anything that's bigger than a density of 1 is going to sink in water. Anything that's less than a density of 1 is going to float in water. And I believe that rock is going to sink in water. We should get a density that's greater than 1. Next, I'd like to do the basalt. There's the piece of basalt. It's nice and black, and it's glassy. For your appearance from the word bank, I would use the dark colored, and I'd use glassy if you want, or crystalline if you want. And I would say that it's a finer grain rather than a coarser grain. This rock is a little bit light. It has some holes in it from the gas as well. Here is the mass. For the basalt, the mass is 7.3. Write down 7.3 grams. Next, I'm going to see if I can put the basalt in the graduated cylinder to check the volume. At this time, I have 100 milliliters of water in the graduated cylinder. And I'm going to set the, you can see, okay, I'm going to set the basalt in there. From 100 milliliters, this went up to 106 milliliters. At 106 milliliters, we'd had a difference of 6 milliliters. I'm going to write down 6 cubic centimeters for the volume. 6 cm to the third. Okay, I'm going to clean these up and I'll be right back. Okay, on step number 2, in order to find the density, you're going to do mass divided by volume. The mass is 7.3 grams. The volume is 6 cubic centimeters. Do that division to get the density and add it there. I'd like to go on to obsidian. Obsidian is the third of the igneous rocks. Here is our sample of obsidian. If you take a look at that, it's a nice greenish color, very glassy, on the dark side rather than the light side. If you'd like to go to your appearance word bank, I would suggest this is shiny, and I would suggest that it's non-porous and that it's glassy in appearance. Okay, and I'd like to check the mass and the volume. Here's the mass of our sample of obsidian. You want to write down on your sheet of paper 29.5 grams. To find the volume, again, I'm going to use my beaker here with 100 milliliters of water. I'm going to gently set the obsidian in there. And I'm going to guess that went from 100 milliliters to 125 milliliters. That would give us 25 milliliters of volume. 25 cubic centimeters, 25 cm to the third. You want to calculate the density there. Take your 29.5 grams divided by 25 cubic centimeters. Page 2, number 7. We're going to do pumice. Pumice is very, very lightweight. This is a rock that will float in water, and you'll notice when I go to do the volume, I'm going to have to use my stick here, and I'm going to push it down in the water to get the volume. Okay. This is very light colored. I would say that it's dull, and it has a lot of air in it, so I would suggest that it's porous. Okay, pumice. I'm going to put it on the scale to determine the mass. This mass is 5.3 grams. 5.3 grams. I'm going to move it over to my 100 milliliters of water. And you'll notice when I put this in here, if you can see okay, it's going to float. And then there's water that's starting to move into it there. I'd like to quickly push it down and get my volume reading. Oh, that's pretty hard. I'm having a hard time. I'm thinking that's going to go up to about 20 milliliters, maybe a little bit less than that. Maybe I'll go down to 18 milliliters. I'm going to write down there 18 cubic centimeters, 18 cm to the third. Okay. To calculate your density from the pumice, you're going to do the 5.3 divided by 18 cubic centimeters. Okay. The rest of the rocks are going to come out another time, and have this much done and then save it for the next video. Thank you.